So we're talking about solving systems of linear inequalities. There are a couple of special cases that come up that you need to be aware of. We're going to follow the same procedures, right? Same procedure we talked about earlier. The result just comes out looking a little unusual, so you kind of need to be prepared for it. And you can see if you look at my first example here, these special cases come up in the same situation where the special cases came up when we were talking about systems of linear equations. Things can get a little unusual when the two boundary lines are parallel. And you can kind of see that's what's about to happen here, since we have 2x plus y and 2x plus y for both inequalities. All right, so how do we graph this? Well, I'm going to do them one at a time. 2x plus y greater than 4. My boundary is 2x plus y equals 4. Solve this for y. This is y equals negative 2x plus 4. So my y-intercept is 4. My slope is negative 2. So I'm going to go down 2 over 1. And I'm going to do this several times, get a bunch of reference points. So my limited artistic ability can get us a decent line. And this will be a dashed line because the original inequality there was strictly greater than. And now I got to pick a test point. I'll use the origin like I always like to when we can. It's not on the boundary line, so that's a fine choice. 2 times 0 plus 0 greater than 4. All right, well, that 0 is greater than 4, which is not true. All right, so my solution is everything on the side that doesn't have the origin. It's everything kind of above and to the left. All right, so that's the first one. All right, how about the second one? 2x plus y is less than or equal to 2. All right, well, let's graph the boundary. It's going to be 2x plus y equals 2. So y is negative 2x plus 2. So my y-intercept is 2. And I've got the same slope, so we kind of know what's going to happen here. We're getting a parallel line, and I'm going to come up and up here. This one will be a solid line because it's less than or equal to. There we go. And once again, I'll use the origin as my test point, and if I put that into the original inequality, 2 times 0 plus 0, 0 is less than or equal to 2. So the origin is part of the solution. So now it's going to be this section over here. And remember, when we're talking about systems of linear inequalities, the solution is the area where the two shaded regions overlap. And you can see pretty clearly here, they do not. Right? There is no overlap. So what's that mean? Well, the points are where they cross and they don't. So what we have here is this situation. We've seen this before many times, right? There is no solution, or you can always use the empty set. All right, if you look back at the inequality, you can kind of see how this happened. We're looking for pairs of numbers where this expression, it's the same one in both of them, where this expression is both greater than 4 and less than or equal to 2. Well, there are no numbers that are greater than 4 and less than or equal to 2. So yeah, okay, right? It does kind of make sense intuitively that there isn't going to be a solution here. So I've got a second unusual scenario here, and you can see I base this off of the same two expressions. It's 2x plus y and 4 and 2 again, just like on the last one. So the boundaries are going to be the same. This one, the y-intercept is 4, and the slope will be negative 2. So it's going to start here, go down along this pattern here, and it's going to go up as well. So, and this is the one that gets the dashed line. So it's going to look like this. And if we test the origin in here, 2 times 0 plus 0 greater than 4. Well, the left side is 0, and that is not true. So the origin is not part of the solution here, which means I want the other side. So I'm going to shade this side over here. So there's my answer. There are my solutions to the first inequality. Now the second one, we also saw this before. The slope, the y-intercept is 2. The slope is still -2. So we're going to really use the same points. Whoops, they're all just one to the left of the original. There it goes. It's going to be like this. And it's going to be a solid line. There we go. And I'll use the same test point. 2 times 0 plus 0 greater than or equal to 2. Okay, that's not true. 0 is not greater than or equal to 2. So again, I need everything on the non-origin side. That's everything to the right and above. Again, it's going to be the same kind of region here. Now remember, we want the overlap. So where is the overlap? Well, it's everything to the right and above my original blue line. So it turns out, in this case, this line really isn't relevant. The solution to this system is the same as the solution to this one individual equation. Okay, that's fine. This is another one of the kind of two interesting cases that can come up when the boundary line really isn't the original inequalities. We can't talk about parallel there per se. This is what happened. One of the situations that can come up when the two boundary lines are parallel to each other.